So let's start working. We have a full 7 tasks to carry out. Basically, this will help us put everything together. The first thing we have to do is to plot the graph according to the values given in our table. This task we did in the first part of the lesson. As you can see, we are now plotting the x and y values in the table. After inserting all the coordinates which are required, we are going to edit the preferences of our graph. In this case, we're opting for a black color and for no line, because according to the question, only the coordinates have to be marked. The next step is obviously to edit the graph so it fits our screen. And here we are labeling the x and y axis accordingly. That is our graph. Our next step is to find the trend line which best fits our data. If you recall correctly, we had mentioned there are various kinds of trend lines which we could opt for. We have here inserted a linear trend line, a logarithmic trend line, and now we are inserting a polynomial trend line. This is a polynomial trend line of order 2. And we are now inserting another polynomial trend line of order 3. By having various trend lines, we can obviously choose the best trend line which fits our data by looking also at the value of r squared in our equations. As you can see from the graph, according to the values of r squared, we have come up with the solution that the trend line that best fits our data is the polynomial of order 3. We have to highlight this trend line if we want to work out the next 2 questions. The next 2 questions are asking us to find corresponding values of y and x respectively. First, we have to find the time value which corresponds to a velocity of 10 meters per second. Our first task is to define the range and the interval which is requested. The smaller the interval, the better the results. As you can see, we are here given the values, and we have to look for a velocity of 10 meters per second. The closest value to 10 meters per second is in fact 10.09 here, which gives us an x value of 8.9 seconds. Next question is asking us to find the velocity at the time of 5.5 seconds. This is perhaps a bit simpler. And the corresponding value of y here is 5.35 meters per second. And we can close the window. Our next question is asking us to draw a second graph of y equals x squared minus 4x over our previous graph. We can do this by opening the insert function window, inserting the function equation, specifying the range and the number of steps, and also choosing our preference for a red colored line. Since both our lines are now in red, it would be better to change the previous graph to a different color. So we could work out question 7 more clearly. Question 7 is asking us to evaluate the point of intersections of the two graphs. As you can see, each graph is intersecting the other at two different points. We choose the intersection option from the snap to slot. That is the first intersection point. And there, in the table, we are given the corresponding x and y values of the intersection point. That would be the second intersection point, and again we have the corresponding x and y values of this particular point. We hope that this lesson has been useful in exploring the basic uses of this graph program. Obviously, there are other features which we could explore in the near future.